Welcome to update 3.8 of the Stream Deck MIDI plugin. This update has some bug fixes, a minor change to the control change button, and some new script features. But let's start with the control change action. In the previous version, you had a checkbox where you could decide if all values above the on value should set the button in the on state, or if only the on value should do that. In this version, there is a third option, so I have replaced the checkbox with a drop-down. And the third option is to have the button only react to the on and off values. So if the on value is received, it sets the button in the on state. If the off value is received, it sets the button in the off state. And if any other value is received, it just ignores it. So let's move on to scripts. And the rest of this video will be about scripting. The first new feature is that you can store strings in variables. If you want a variable to store a string, you enclose the value with quotation marks. You can do without quotation marks, as in the first row in this script, if it is obvious for the script engine that the value is not numeric or does not include any special characters. But it's always safer to enclose the value with quotation marks if you want the script engine to treat it as a string. So the first time I press the button, it shows the value hello. And the next time I press it, it adds world. If you want to have the text on multiple lines like this, you can include the \n command, which is a new line command. This new ability to store strings can be used in time commands. Previously, you could only have text actions in time commands, but now you can also set a variable in a time command. The syntax for variables is the same as for text in time commands. I have two buttons, one button that shows the running time and I can start and stop my sequencer with that button. And I have another button that stores the latest received time in a variable, and when I press that button it shows the stored time. So if I start my sequencer, it shows the time on that button, and I stop it, and if I press the other button, it shows the latest time it has received. The last new feature for scripting is that scripts can now receive sysx commands. And to understand what I am saying now, you need to understand what sysx is, and you need to understand hexadecimal notation. The syntax to receive sysx looks like this. You have a sysx event where you have a sysx string with the characters XX somewhere in the string. This XX is the variable part of the sysx string, and for the command to react, everything else in that sysx string must be exactly as defined in this event. I have a utility with which I can send sysx commands, and here I have defined a sysx command that conforms to the structure in the sysx event in my script. The F0 and F7 are the mandatory sysx start and stop bytes. And as I have defined this sysx event in the script, it requires that the first 2 bytes of the start byte is 0120. If it is not, the script will ignore the received sysx command. Everything between 0120 and the final F7 is the variable part. It can be of any length, and the content will be saved for access in the actions in this command. The XX part is not saved for later actions in other commands. You need to take care of that content in this command if you need it. In the actions, there are some event reference variables you can use. You have this e_sysx variable. So if I send this sysx string, you will get the exact hexadecimal representation as in the sysx string displayed on your button. You can use the event reference variable sysx value, in which case it will take the first byte from the variable part and convert it to an integer value. So if I send the sysx string now, I will get 72, which is the integer value for hexadecimal 48. Finally, you can use sysx text, which takes the received bytes and treats them as ASCII characters, so you can send text in sysx commands. If I save this and I send the sysx command, I will get the text displayed. And the conversion is made with the ASCII table, which defines a number of characters that you can use. You have this table where you have hex values and you have the character that is represented by that hex value. So you can pick and choose from this table to display characters. It can only take characters that are available on a US keyboard, unfortunately. There is an extension to this ASCII table that includes other kind of characters, but that extension cannot be used in sysx because the values are too great. You cannot have values higher than 7f in a sysx string. If you want a command to trigger on an exact sysx string without any variable parts, if you want the script to just do something when that sysx string is received, you can remove the XX part, in which case it is required that the sysx string looks exactly like this. And of course, in such case, you cannot reference sysx values because the XX part, which contains the values, doesn't exist. That's all for this update. Thanks for watching.